Okay, so let's move on. And one more thing I would like to show you is that, of course, in software we use accessor keywords or labels that specify public or private level of access. And likewise, in UML, a minus indicates, oh, actually I need to switch over to my drawing mode, right? So a minus will indicate private. A plus will indicate public, right? So if you look back to the code, you will see that you can have private and public members of your classes. So there is minus and plus represents public and private. I will actually right now get rid of these because they just simply we will assume that all methods that we use are public and all data all member functions or methods are public and data attributes are private. Okay, so that's the assumption that I will use right now, just not to overcrowd my drawings over here. So back to the thing. Is this a code visible? Do you want me to change the font a little bit, or is this okay?
Would you be able to make it larger?
Yeah, yeah, I thought so. Let me try to make it a little bit larger, like this, maybe, right? Yep. And just then resize this. Okay. So I will tell you that this example is not entirely written from me. This is from public domain, one of the links I got off of the Wikipedia. So this is public domain, a code. There is no copyright on it. But I just want to mention this origin because then I would like to also mention that this was written a few years ago. So this is not really the best style for what you can use nowadays in programming using C++. For example, this would be normally used as null pointer, for instance, and then also this declaration of a factory, which is, by the way, a factory object that allows us to manufacture parts, manufacture other objects. Obviously, it's like declares the variable and then assigns it. I think that this is like really should be written just like this. It's really confusing this way. Notice a check for if pointer. Obviously, a factory is a pointer to the maze factory. And it basically checks whether factory did return some valid object, because this if is similar to saying if this factory does not equals null pointer, right? Because apparently if this factory instance call returns null pointer, of course we can essentially tell them that something was wrong and so forth, right? So it basically makes this check because there's a possibility that this thing returns back a null pointer, right? So, but rightfully so, most of the C++ people will just simply write this because if it contains anything valid, it means that the pointer is real, right? Because we know that it really points to something. Right, so then it will call this game, who is the maze game, and say create factory, and will pass the factory to that object. So again, in our diagram, we have the maze game that has the method that says create maze, right? Create maze, and maze wants to have the factory access to the factory so that they can use the factory to manufacture the maze. All right. So this is what we have so far. So the maze is the thing that we want to construct. The maze game is essentially a helper object which oversees the work in the entire project. The factory is a helper object. We want to create a factory which is a helper object to create other objects, and but the factory doesn't know what to create. Someone has to tell it what to create, and this maze game class has a method to create maze which apparently knows what to create. So let's take a look at what gets created inside create maze. Let me see. Well, first of all, let me just build this again so that we're current and up to date. So I will now, I should be able to just go to definition and jump to it, and it happens to be inside mazegame.cpp, which is the implementation file. Again, resize this a little bit, right? So let's see what happens in this create maze function, which is part of the maze game, right? So this is, we're now looking at the actual code for this create maze method that belongs to the maze game, right? Of course, there's all kinds of syntax involved, and again, this is an older version of C++. For instance, the use of classes is absolutely unnecessary over here. Most people won't use it. Likewise, they will not use it right there as well on the return type. But as you can see that it's optional. It can be used. Okay, so create maze is a method that belongs to the maze game class, and it takes pointer to this mysterious factory object that we need to be able to work with. All right, so first of all, what it does, it basically says, again, I will simplify the code as much as I can. It says, let's create the maze. And apparently there is a method to say make maze part of the factory, right? So perhaps right now, since we already in the driver.cpp, which contains main, we already have constructed the instance of our factory. So perhaps let's take a look at the maze factory class before we continue on to see what's happening in create maze, right? So we need to find it. Okay, we need to find this, and what I would like to do is basically just tell my environment, just show me the declaration of the maze factory. So here it is. It's actually inside a file called singleton, because apparently in itself it has element of another design pattern named singleton. This is absolutely unimportant to us right now. So singleton.h, class. So this is actually just a pointer. Maze factory. Where is it? Okay, so here it is. So I'm just like trying my best to navigate through the code. Open maze factory.h, which is the header file, and you can see that the original code base was written in German. So this is called saying in German forward declarations of classes. Anyway, so we have this maze factory thing, which we would like to also document. Let me just close this for now. And so this is our attempts to use UML by just using something very, very simple, just this type of drawing. So the next thing for us to take a note of is this class factory. Of course, it will also inherit from object from this class, but I will ignore it for now. And just simply say, perhaps over here I can say maze factory. In fact, let me move it here first so that I can have space to do stuff. Factory, right? So this is another another class that I would like to document. In terms of the data, there is no data, right? So I don't see any data. Everything here is just virtual methods, which are abstract methods in Java. So there's no data. Again, the data attribute section is empty, just like this. However, I'd like to keep it in my UML to keep my UML notation legal. Then I would like to say that there is, of course, the constructor, which again does not have any parameters. This is the constructor of this class. Then it has all kind of creational methods: make maze, make wall, make room, make door. Okay, and notice that when we say make room, it wants to take an integer which represents the room ID, internal unique ID number for the room, and then we say make door, it wants pointer to two of the rooms which the door will be connecting. All right, and there's also print. Apparently print is part of everything. So let's just go and quickly run down this entire set of things, and so we will have another box. So it has make maze, right? Make maze. It has make wall. It has make room, right, and make door, right. So make room takes a number which is an integer, which is obviously an ID of the room, and make door actually takes room 1, right, and room 2, obviously, which are rooms, and that's the notation in UML. You specify like basically the identifier, which is followed by the column that specifies the type of this thing, right? Room 1 and room 2 are both rooms that the door will be connecting, okay? Then, interestingly, you will see that, again, let me simplify this as much as I can to simplify this older, like really kind of formal C++ over here, just to simplify it to this level. Okay, and now just want to say that all the make methods, make maze, wall, room, and door, actually return a pointer to, in Java would be a reference to, a maze, wall, room, or door object, and in UML, this is documented again. So this is the name of our method. I can even use like empty parentheses, that's legal in UML, and the return type is specified at the end, again, not in front of the name like we do in software, but rather at the end. So this returns an object of type maze, right? This returns an object of type wall, right? And these two, apparently this one returns a room. So this is the UML notation. And this is the door, right? Returns the door. Okay, so these are let's finish with the set of methods first. There's also print, right? So print is also present here. I will keep it print. All right, so print. So this is my, again, in UML we use boxes to represent classes. In software, we use curly braces to provide bodies for classes and everything else, right? So this is just another box which doesn't have any implementation details, but you can get a sense that the maze factory is responsible for creation of maze, wall, room, and door. Okay, so these are the three, actually four make methods which exist inside there, and of course the the actual methods are just like basically their names are here, right? So these are the actual method names, right? So we can highlight them. Everything else, besides the actual method, is optional in UML diagram, right? So only these names are required in UML. The set of parameters, the return type, these components are all optional. Again, many people will use the name of the class as the name of the constructor. However, many people prefer new because new is very short and is very easy to spot, and especially when it's at the top of the set of attributes. So that's one of the conveniences that you can have. And of course, like the final touch is that of course this class also, let's change the color as we used before, right? So this class too belongs to derives from an object, because it just seems like everything in this particular application derives from an object class. Okay, let's move on. In fact, it kind of bothers me a little bit that we use different, let's just use the same color to fill in our drawings. It just makes it a little bit easier to see, and perhaps if I switched, let me just, I don't know where it's losing its part, but trying to fill this in, I don't know. I'll just not waste my time with this. But anyway, so this is the UML diagram. Of course, if I was again, this is just like has a break somewhere so that I'm losing the area here, which I'm trying to fill to. Okay, so this is what we have so far. In this analysis of what's going on in the software, right? So truly, this is nothing to to get stressed out about. I mean, all of a sudden, there's so many different files, and these are just the implementation files. There are also header files. However, there's not much to be stressed out about. You try to understand what's going on, and perhaps using UML is one of the ways to say, okay, if I just draw these boxes and look at them, they will give me somewhat better understanding of what's going on, right? What's involved.